Yes, friends. So we are doing now question number 3, part number 4. That means y equal to cosec inverse x. This graphically I have understood, or I have discussed about. Okay, we have understood this. Okay, so next let me take what is secant inverse x, and as I am comparing them, sec inverse x and just secant x, or if x equal to or y equal to sec theta suppose, how that is to be graphically drawn. Okay, so graphically we have to understand both secant theta and secant inverse x. Okay, secant x and secant inverse x. So first let me take, this is the fifth one. Let y is equal to secant x. Now we know that what is secant x, value of x. If I put here angles, what are the angles? At 0 it is 1 and out. At pi it is -1, just like cos x. But at 90 degree, if it is 90 degree, okay, sin 90 upon 1 upon cos 90 is 0, so it is not defined at 0. Okay, and at at 0 it is defined, but at pi by 2 it is not defined. At 3 pi by 2 it is not defined. Okay, so at 3 pi by 2, pi by 2, etc. This angle is not, secant x is infinity, is infinite values. So how do we draw them? Let me graphically draw that. Okay, so graphically, if I draw that, draw a graph here. This is x-axis, x-dash, it is O, y, and y dash x. Now, as you know that at 0 it is 1. So if I put angles in terms of angles, it is 0 here, it is pi by 2, it is pi, it is 3 pi by 2, it is 2 pi here, middle values are taken. This is minus pi by 2, it is minus pi, it is minus 3 pi by 2, and it is 2 pi, minus 2 pi. Okay, and maximum value or value of y will be 1, maximum 1 here, or we have to take here for the maximum value. Maximum value y is either 1 minus 1. Okay, so that values we have to take here. That 0 it is 1, just like cos x. When it is 0 here, 0, it is 1 value. Okay, but at minus pi by 2, the value is this. So if I draw the parallel lines through 90 degree of pi by 2 along the y-axis and the 3 pi by 2 along the y-axis, and through minus 3 pi by 2, etc. Because at 2 pi it is 1, but at 3 pi by 2 it is 0. So it is infinitely not defined. At pi by 2 it is not defined, it is infinite. What the value of that? So if I just take here at 0 it is 1, this is 1 here. Let me take this is 1. Okay, and here I take minus 1. Okay, by minus 1, this is by positive 1. So at minus 1 and at plus pi by 2 it is at infinity, not defined. This is by at 1. This is the graph of this. Secondly, this is your pi by 2 to 3 pi by 2. That means second quadrant. This is 3 pi by 2 and up to pi by, at pi it is minus 1. If I take here minus 1, this is minus 1 here. But at pi by 2 and 3 pi by 2 is 0. Okay, so it is 0 here. So that kind of graph it will be. This kind of graphs will be there. Next, if I take at minus pi, it is undoubtedly minus 1, no doubt. Okay, so it is minus 1 here, and at minus pi by 2 it is 0, minus 3 pi by 2 is 0 here. So at this minus 1 this is -1 here. Again, this kind of graph is there. Okay, so this graph, and here it will be positive at 2 pi, it is +1, it is +1 here, at 3 pi by 2. If I take from this side, and next will be 5 pi by 2 positive. At that also this is like this. Here the graphs. Okay. This is the graph of secant x. Y equal to secant x. Y it is 1 -1 either maximum value, and at pi by 2, 3 pi by 2, 5 pi by 2, etc. A multiple of pi by 2, 2n plus 1 into pi by 2 is not defined. That at that number, I mean at that angle, it is infinity, not defined. Okay. It is 1.0 in that situation. This is how the graph of this is secant x y equal to. Now let me take what is secant inverse x. If I define, if I take y equal to sec inverse x, in that situation what the graphical representation is. Let me take it as y equal to sec inverse x, y equal to secant inverse x, and y equal to secant inverse x. Let me draw the graph. Again, in this situation, now we have to take x numerical values, -1 +1 either, or y can be then infinity, okay, or at 1 -1 it is 0, it is pi, sorry, it is at 0. When it is 0, it will be at pi by 2. Okay, at 0, sorry, at pi by 2 it is not defined because this sine 1 on cos pi is 0, cos pi by 2 is 0, and net cos pi by 2, if it is 0, then it is infinity, not defined. So let me take the angles here. Here it is pi by 2. Let me take this is 0, origin O, x-axis, this is y, and y dash axis. In this situation, this is -pi by 2. Because by resultant will be angles, and this x we have substitute numerical values. In that situation, this is -pi, -3 pi by 2, and this is -2 pi. Up to this only let me take. This is pi here, this is 3 pi by 2, and this is 2 pi. Okay, so let us take 1 and -1 again, and this is 1 here, and this is -1. Let me take. Now, if I draw the graphs in case of, well, at pi by 2, it is not defined. Draw the line parallel to the x-axis, parallel to the x-axis, parallel to the x-axis through pi by 2, or multiple of pi by 2, and this is at -3 pi by 2. Okay, this is the graph here. Now let us say, sorry, this is the straight lines here. Now because at 0 it is 1, but at pi by 2 it is infinity, not defined. For the 1 point cos 90 degree is 0. This is asymptote type. This kind of asymptote here at -pi by 2. Again it is not defined, so it means at infinity. Okay, this is straight line along parallel to the axis of x. This is the graph here of secant inverse x. Okay. Next will be negative. At -pi, undoubtedly it is -1. Okay, so this is -1 here, but at -pi by 2 it is 0. Sorry, at infinity. At -3 pi by 2 also it is infinity, not defined. This will be the graph here. The graph of this kind. Again here at pi it is -1, it is -1 here, and at 3 pi by 2 it is infinity, again infinity. This is the graph of this kind. Okay. Again here it will be positive, here it will be positive. In this way the graph of secant inverse x can be drawn. If you take the value of secant in first quadrant, second quadrant, third quadrant, fourth quadrant. In fourth quadrant, secant is positive. Okay. Sec 2 pi minus theta, this means 2 pi minus theta, it will be positive here. At 2 pi, it is 1 positive. This is positive here, but it is in the fourth quadrant. The value above this 3 pi by 2 pi, it is in the fourth quadrant. So that will be positive. Plus 1 here, this is 1 in that graph. This kind here, graph, it is minus 1 here. This way, it is minus 2 pi. Okay, so that is how we have to go. Sorry, this will be positive 1. Minus 1 is here. So it is plus 1 here. But this is minus 1 in this case, is minus 1 this side. This is plus 1 on this side. Minus 2 pi, even if it is 2 pi or minus 2 pi, secant 2 pi is plus 1. Minus 2 pi is also 1 because sec minus theta is positive theta. That is sec 2 pi. Sec minus 2 pi is into sec 2 pi. Sec 2 pi is 1 positive. This is 1 here. And graph will be like this. Okay. In this way, secant inverse x we have drawn. So this is how we have drawn the graph of the secant inverse x. Graphically, we can understand these trigonometric inverse functions. Okay, or inverse trigonometric function. Now let me take the eighth one, which is of cot inverse x or cot x. That is next point. We first clean it. Okay, now cot inverse x and cot x, comparative graphs of that. Graphically, you can understand how trigonometric functions and inverse trigonometric functions or circular functions are to be understood. So, the sixth one is let y equal to first cot x, let me take, and cot inverse x. These two are to be compared. Let me take first cot x. This is okay. Now, in the case of this cot x, because tan 0 is 0, why? Tan 0 is sin 0 1, cos 0 is 1, but sin 0 is 1. 1.0 is, sorry, 1.0 is 0. Tan 0 is 0, and pi is 0. Then pi is also 0, because sin pi is 0. That means whatever the value of tan pi, that is how that pi is, or tan pi is 0, but that means cot pi will be 1 upon tan pi 1.0. That means it is not defined at pi. Because tan pi it is not defined. Now let me check what are the values here. The maximum value of this will be again infinity, it will be, but at what point it will be infinity? Pi by 2, 3 pi by 2. At these points it will be infinite value, not defined value, because sin pi by 2 and cos pi by 2 is 0, or this is cos pi by 2, sorry, cos pi by 2. Let me take here, this is cos pi by 2, which is 0 here at cos pi by 2, and sin pi by 2 is 0. Is 1 to is 0 from 1 is 0. At pi by 2 is defined, but at pi it is not defined here. Okay, so let me take at pi it is 0. At pi it will be 0, but at 0 it is not defined. So that is the point we have to discuss about. Okay, and pi, 2 pi, and 3 pi it is infinite value. Okay, or 0 it is infinite also, because cos upon sin 0 is 1. Not defined. At 0 it is not defined. I'll take here. Okay, and so let me take x points. X is first pi by 2. After 0, I will take origin. Then this is a pi, 3 pi by 2. This is 2 pi after this, minus pi by 2, minus 5, minus 3 pi by 2, and this is minus 2 pi. All these points, these angles we have taken. Okay. Now, in case of at sin 0, it is not defined. We have to just take at pi it is 0, pi by 2, It is 0 because cos pi by 2 becomes sin pi by 2. Cos pi by 2 is 0. 0 upon something 0. At this it is 0. Cos pi by 2, but at 0 it is not defined. Okay. So how the value will be? We have to draw lines parallel to the at pi it is not defined, at 0 it is not defined, at 2 pi it is not defined. At pi minus pi it is not defined. At minus 2 pi it is not defined. We draw straight lines through these angles. Okay. Now at 0, sorry, at pi by 2 it is 0. So the value will be like this. Okay, these kind of lines are there. Let me draw this properly in the same fashion as we have drawn here. Similarly, in this case, at 3 pi by 2 is 0. The other straight line. Again, this is the straight line. Negative point. Again, this is the straight line. I mean, this is a asymptotes here. Asymptotes which are meeting at infinity. Okay, along the points pi, minus 2 pi, etc. Because this is not defined. Pi because pi upon sin pi is 0. 1 thing upon 0, 1 upon 0, or minus 1 upon 0. That means infinity. So it is infinity at that situation. At pi it is infinity. Okay, but at pi by 2 it is 0. 3 pi by 2 is 0. 0 means it is meeting the exactly that 0 point. Okay, at this point. This is the y equal to cot x. I mean graphical representation of y equal to cot x. Now let us say this is x axis here. X axis, this is y axis and this is y axis. In this way, in coordinate axis we have taken this representation of the asymptote, sorry, in case of cot x. Y equal to cot x here. Now let's say y equal to cot inverse x. Okay, so our objective for today's topic is, today's lecture series is trigonometric, inverse trigonometric functions, or inverse trigonometric functions or ratios. I mean, so let us say these parts. Okay, so this is the question number 3 we are talking about. Now let us say cot inverse x. This is cot inverse x. Y equal to cot inverse x. If I take these points again. So in this case, x we have to take the numerical values. 0 or minus 1, plus 1, etc. Okay. Which is 0 here or infinity only. Here. Y equal to, suppose, any angle. If it is pi by 2, then x equal to cot pi by 2. Cot pi by 2 is 0, not defined. But cos pi upon sin pi, so that is 0. Okay, so it means we have to take here, this is pi by 2, this is 0 here, origin, x-axis, x-axis, this is y-axis, y-axis. Now try to understand. Pi, this is pi here, pi by 2, and pi, 3 pi by 2, and here let me take pi. Similarly, minus pi by 2, minus pi, minus 3 pi by 2, and this is minus 2 pi. Okay, so that is the other points. Now, in case of these points and these points, we have to draw at pi, it is not defined, at 0 it is not defined, at minus pi it is not defined. Draw the straight lines like this, to pi also, to 2 pi also, to minus 2 pi also. So at 2 pi, at pi, this is not defined, cot pi is not defined. While cot pi is equal to cos pi upon sin pi. Cos pi is 1, okay, but sin pi is 0. 1 from 0 is not defined, infinity. At pi it is infinity, but at pi by 2 it is 0. So what is the graph here? Graph will be of this kind. This is the asymptote which is meeting the this is straight line at this point, and at 0, okay, at 0 it is 0 because cos 0 from sin 0, not sorry, at 0 it is not defined, sorry, at 0 it is not defined, but at pi by 2 it is 0. At 0 it is not defined, then we take this 0. This is the straight line which passes to the origin, because this is the straight line here. So that pi it is not defined, at 0 it is not defined, meeting at the infinity. Okay, similarly, at this point 3 pi by 2. 3 pi by 2 asymptotes here. Passing to 3 pi by 2 at 0. Pi is 0 here in this case, at 3 pi by 2 at pi by 2, at minus pi by 2 at minus 2 pi by 2. This is another asymptote passing through minus 3 pi by 2. These are the asymptotes, graphical representation of cot inverse x. This is how cot inverse x we are represented. Okay, so graphically representation of trigonometric, inverse trigonometric functions are the all the ones are very obvious, very clear. Now let's take question number 4. What is question number 4? These are properties of, we have to discuss now, what the properties of inverse trigonometric functions. Question number 4, which is about properties of. Some properties, basic properties are there. Let me discuss about them and how those properties are there. Some of the questions are taken here based on the properties. But before that, let me take those properties. This is question number 4 here. It says what are the properties of inverse circular functions or trigonometric functions. Inverse circular functions. The properties of inverse trigonometric functions. Inverse trigonometric functions. The properties are taken. Inverse trigonometric functions. Okay, properties. Number 1, first kind of property or property of first type of first type. So type 1 we may say type 1 or type 2 or theorem 1, theorem 2. In that way we define theorem 1, theorem 2, theorem. In that way we define. So what is the first theorem here that we take? If I take cos inverse, this is the a part of this. Let me take first sine. Sine inverse sine theta is equal to of sine x. If I take, let me take x here. Sine inverse of sine x is equal to x. Okay, where x belongs to minus pi by 2 to plus pi by 2. This is the case of angles. Sorry, this axis belongs to minus pi by 2 plus pi by 2 because sin pi minus pi by 2 is 1, minus 2 plus 1. So this is the value of x here, sin inverse x of sin x. Or we will take sine of sin inverse x, anything we can take. V point. Cos inverse of cos x is equal to x again. Here x belongs to, okay, this is 0 to pi in case of this C point. Tan inverse of tan x is equal to x. Now here x belongs to, because this value is the set of real numbers, but angles here are minus pi by 2 plus pi by 2. Okay, x belongs to minus pi by 2 plus pi by 2. We can take, because at these points this is infinity. Okay, this is infinite value lying between minus infinity to plus infinity. All the values are there. So set of real numbers we could say that belong to real numbers. We can take x belongs to real numbers. Or what is real numbers? includes all kinds of values. That is how x belongs to set of real numbers we have taken. This is pi by 2 mass pi by 2 pi, okay, or set of real numbers. We can take, because all the values lying between these two are infinite maximum 2 plus infinity, that value. Now fourth point, which is d part here, we take only this value. Okay, now 10, after that cosec inverse x, let me take cosec inverse x of cosec x equal to x. Now in this case, again x belongs to here, minus pi by 2 plus pi by 2. We can take minus pi by 2 plus pi by 2. Okay, because x cos pi by 2. So it is 0 to pi we have to take, because at 0 to pi the values are lying in between. We can take this as 0 to pi here. Okay, or cosec inverse is minus pi by 2 pi by 2, but minus 0 we have to take. This is minus 0, because that's minus 0. The value is not defined. One count sin 0 is eliminating this limit is okay. This is the value here. Then c part, let me take second inverse x. Second inverse of second x. This is also equal to x, where x belongs to 0 to pi. Okay, and this is minus sign, but we have to remove here at pi by 2, because at pi by 2 it is infinity, 1 count sin pi by 2. So all kinds of this pi by 2 or sin pi by 2, but in between the 0 to pi, this is pi by 2. We have to remove pi by 2, because that pi by 2 the value is not defined. That we have to remove here. 0 to pi minus pi by 2. Okay. Then f, the sixth type of property, this is cot inverse cot x. This is also equal to x. Here x belongs to 0 to pi. At 0 to pi here, that pi by 2 is okay. This is 0 at pi by 2. At cos pi by 2 also it is 0. Cos pi by 2 upon sin pi by 2. But at 0 to pi it is not defined. So we can say x line between, this is smaller bracket, because 0 and pi are not included here. The values are in between them, 0 to pi. It is smaller bracket here. The smaller bracket, this is all the points we have taken. Okay, so in cot inverse x, 0 theta belongs to, or x belongs to 0 to pi. Okay, this is smaller bracket here that we have taken. Okay, because this, all the values lying between this. Okay, so this is the first type of property we have taken. Now let us take first cos x and then cosec inverse x. In that situation, what are the numbers? Second type of properties, the property of type 2, property of second type. This is second type of property. Second type of property. Again, let us take the 6 mode. I noted down it. Points here. A point, first type. This is sine of sine inverse x. This is also equal to x. Now here x belongs to, here x belongs to minus 1 to plus 1. B point. This is cos inverse x. This is also equal to x. Cos inverse x equal to x. Here x also belongs to minus 1 and plus 1. First maximum value, minimum value of cos x is also minus 1 and plus 1. Okay. Then C point. Tan of tan inverse x. This is also equal to x. Okay. Now here x is minus infinity to plus infinity. You can just say all x belongs to set of real numbers. Why s belongs to set of real numbers? Because here x is real numbers. Infinity to minus infinity plus infinity. We'll just talk about minus infinity plus infinity. Okay. Now it is tan inverse x, so set of real numbers. This is set of real numbers we have taken. Now next thing is cot inverse x. Okay. That is also x belongs to. Alright. Now this is the third one. Now D part. Let us take first cosec of cosec inverse x equal to x here. Sorry, this is cosec of cosec inverse x equal to x. Here x belongs to. Now set of real numbers. Minus sign. Here minus 1 and 1. These two values removing minus 1 and plus 1. Except those two values. This value is defined. Okay, it's set of real numbers other than minus 1 and plus 1. The remaining values we have to take here. E part or the fifth one. This is second inverse x. This is also equal to x. That gives us here also x belongs to set of real numbers minus 1 and plus 1, just like that of cosec inverse x. Then f, the cot inverse x. This is the sixth property, second type property, also equal to x. Cot inverse x also equal to x. Here x belongs to 0 to pi. Sorry, 0 to, not in numbers, but it is set of real numbers answer. This set of real numbers here. So in case of cot inverse also, tan inverse also, tan of tan inverse, x belongs to r. In case of cot also belongs to r. Okay, so x belongs to r. This is the second kind of properties of the inverse functions. So second kind of property I have taken. Okay, the second kind of property. And let me take the third type of property. Okay, third type of property is of what kind? So property number 3, negative values here. Alright. That means okay, that is there. X belongs to cot inverse is x belongs to r, tan inverse is also x belongs to r, that I was just searching for. So this is of second type of property. Now let's take